A very interesting electrophilic aromatic substitution reaction is one called Fridel-Crafts alkylation. This reaction allows us to add an alkyl group onto our benzene ring, or substitute an alkyl group onto our benzene ring. And so the mechanism is kind of similar to what we've seen with the bromination and the chlorination, except in this case we're not using Cl2 or Br2. We're using an alkyl halide. So to begin, we're going to, just like with those chlorinations or brominations, the chlorine group is going to attack the metal complex here. So in this case, it's AlCl3. So and just like before, that center halogen is going to be positively charged. So you're going to see that in a minute. And that leads to instability. Okay, so we're not going to want to have a positive charge on that chlorine, and so what's going to happen is it's going to pull electrons away from the carbon chain, and we are going to have AlCl4, and we are going to end up with positively charged carbon, or a carbocation at that location where we had the chlorine attached. This is again an electrophile. It's a strong electrophile, and so this strong electrophile is going to be attacked by our nucleophile, just like we've seen before in benzene. So on this page, let's go ahead and draw what's going to happen with the benzene. And so benzene will attack the carbocation, and we're going to form that sigma complex again. But in this case, it's an alkyl group being added on. So again, this is the sigma complex. There's resonance you can do here, and I'd highly recommend you continue to practice drawing these resonance structures as you are doing your practice of drawing these mechanisms, so please do that. So what's going to happen? We need to reform the aromatic ring, and again, just like in the bromination and chlorination, the halogen falls off that metal complex and it will deprotonate the hydrogen here where we're trying to substitute the alkyl group on. And so these electrons reform the aromatic complex, making it more stable again. And we have formed or substituted the alkyl group onto this aromatic ring. Now there are a couple rules regarding these types of reactions. The biggest rule is that we don't want to do this with any primary alkyl halides. Primary alkyl halides will lead to a carbocation rearrangement. This reaction is really fast, and so it doesn't allow the carbocation rearrangement to occur fully, and you're going to end up with a mixture of products. I've gone over this in the notes. I highly recommend that you look through that and make sure that we are not doing any alkyl or Fridel-Crafts alkylations with primary alkyl halides, and that we have or we do them with only secondary or tertiary alkyl halides.